taking a quick pause. However, we will be continuing these sessions on a weekly basis on Fridays, and we also have the sessions for our North American and European customers run by those respective teams. So this is a seminar in regards to our consistent topic, which is, of course, the Megaport roll-up on complex networks, being simplified. Today, as I mentioned on this session, we're going to be talking about Azure and ExpressRoute. Quickly, a little bit about myself. Jason Bordujenko is my name, JB. For those that are watching via LinkedIn, you'll be able to get to my details on the speakers tab, so please feel free to connect with me there. And if you do have any questions, you might have a couple of means that you're joining us today, hopefully via the LinkedIn stream, or you're connected to our Zoom instance where you're registered. If you're using Zoom, simply put a question in the Q&A area, and myself or my colleague Ryan Tucker, who's handling questions today, we'll be happy to answer that for you. Otherwise, if you're on LinkedIn, and I can see we've gone live with LinkedIn, which is great, then you can feel free to put the questions through there as well. If we don't get to them this week, obviously will be rolled forward into a future week or perhaps even a future topic. So I head up the solution architecture team at Megaport based in Brisbane. You can email me at jb@megaport.com. You can find my other little repositories of data and information there. What we'll be talking about today, as I highlighted, is actually connectivity in a couple of mechanisms of the Megaport aspects, which we're going to be using the MCR, Megaport Cloud Router, and we're going to be connecting to Azure for the ExpressRoute service here today. We'll do that, as I said, through the MCR to show private peering connectivity as well as Microsoft, or what is known as public peering connectivity, through to Azure in that mechanism. And what does that actually gain you access to? The MCR is an interesting way to demonstrate this because we can actually stand up that public connectivity, the public peering, in a matter of minutes. And that's why it's great to do on a session with the time constraint as we've got through a session such as today. We will leave some time for Q&A. The other way that I'll demonstrate it is connecting that same Azure ExpressRoute through to a Megaport. So if you're connected to one of our ports in data centers globally, that is over 800 data centers where Megaport has a point of presence, your routers can actually terminate that Azure ExpressRoute natively, or you can even use a combination of the methods that we'll show today in putting the MCR in line and utilizing that to stand up the faster or the more expedited connectivity to Azure, and then you can bring the result of that routing path back through your port. Might even be a switch that you terminate to. So these are a quick overview of what we're going to be looking at on today's chat. So firstly, the process, we won't actually go through the full process end to end. This is documented well on the Microsoft and the Megaport websites. But what does it mean to have an Azure ExpressRoute circuit? And when we use the word circuit, it actually implies a circuit pair. So we'll speak about that in a little bit of detail once we've gone into the demo phase. As I mentioned, for the peering types, distinguishing the difference between what is a private peering, that is access to your Microsoft resources that sit within a private IP range or subnet. The Microsoft term for this is VNet. So effectively connecting from your VNet through to existing infrastructure in a hybrid connectivity method. The Microsoft services, that is the platform-based services or the software as a service-based services, it's a mouthful, getting access to those services does generally require some extra networking knowledge. Usually that's been a consideration for our customers that are utilizing ExpressRoute because they need to use a tunnel encapsulation method. 2 layers of VLAN tags is the way that we put that. And traditionally that's been known to our customers when we've spoken about this in the past, and we've had many webinars on detailing this subject. We've called it Q&Q, and that is the terminology where a single VLAN is known as a .1Q VLAN, and then Q&Q implies that there are 2 layers of VLAN tags. There are some challenges in doing this, however. Is it still required? Yes, if you wish to access multiple Microsoft services on a single ExpressRoute or ExpressRoute pair, Q&Q is still enabled by default by Microsoft. There are methods now that I want to speak about, that new options that have been developed and delivered in our portal, and obviously via the MCR, which is our cloud router product, that will enable this to be broken out, or in fact translated to a single tag if you're connecting straight to a Megaport, And if you're utilizing the multiple service offerings, the different peering types, we can actually break that out straight to an MCR as well, and that's an automated process. All right, so I think that's probably enough on the slide where let's get to a demo. Hold up the phone whilst we pull up the dashboard. All right, so we'll go back to full screen here. So we'll start in the Megaport portal. I have already ordered a couple of services just to speed up where we're at today, and I'll step between here and the Microsoft portal as well. So let's get to those two. I've just brought the tabs back so I can swap between. The first one that we're seeing is what we've provided in a previous one of these sessions, where it is a physical Megaport port. This is a 10 gigabit per second port that's been ordered in one of our partner data centers in Melbourne. It's the DXC Technology Data Center. It's not going to be plumbed in or configured to physically connect to anything today, but if I was doing that, I would be downloading the LOA and sending that to the data center. If I had equipment within that DC, it would be live already connected to that port. And we can notice again straight away that we have the quick connection tabs. Those are available directly under a configured port that has no active services on it. So they're the quick access or API integrations. And obviously the one we'll be speaking about today in some detail is Azure. So I will click on Azure for that port. For Azure, when we click on that particular tab, we can see the initial view that is presented is a request. It's a request for information for more detail on providing this Azure connection. And what is requested at this point is a Microsoft Azure service key. For those that are familiar with that particular format that you can see with all zeros there, that is a GUID or a globally unique identifier. And that is a string of characters, numbers and letters that are used to identify the specific service that we're going to be connecting to within Azure. There are some steps there on how to get an Azure service key if you don't have an ExpressRoute service key already. But even in terms of a customer who's looking just to understand the pricing, there is a separate tab. This will not create the order at this point, but if I wanted to get an estimate of connecting to Microsoft, where is that available? So by selecting here pricing, I'm filtering by Australia, as that's where we'll be doing the demonstration for today. We can actually see of those 240 ports that are connected, the NNIs between Microsoft and Microsoft and Megaport, we can see where those are located. Now, these choices are somewhat made on your behalf. Some of these decisions are made when you stand up the ExpressRoute key or the request for the key, but scrolling through here will show all of the points of presence where we can connect to the Microsoft Azure Edge and those ExpressRoute locations. So we can see here, if I scroll down, multiple data centers here in Melbourne, across Perth, multiple in Sydney. There's actually two edge connections there. There's Sydney and Sydney 2. And Sydney 2, as you can see, is the NextDC S1 footprint. You'll also notice on the right-hand side the diversity zone icon. So that is indicating red or blue for diversity. And these are what is effectively formulating the Azure circuit pair. So once a circuit has been stood up on the Microsoft side or requested via a service key, it will select automatically a pair of these Megaport NNIs that are spread across the red and the blue diversity zones automatically. But for pricing purposes only, I might say, in this case, I am utilizing a port in Melbourne and I want to connect to, let's pick one at random, this particular port. And for today's purposes, we're actually going to be using a 50 megabit per second service, but that would be a flat rate pricing up to a gigabit per second and then a price that's flat rate between a gigabit per second and the maximum there, which is indicated as 10 gigabits per second. The Megaport cost element there is indicated just as a guide. I can't actually proceed to make the connection without coming back and using the specific service key. So how do I get access to that service key? Great question. Glad you asked. Let's go and have a look at a couple that we've prepared. I won't stand up a new one. I'll actually use one of these, but I'll actually show the process. So I've gone in here to the Azure console. And previously you can see there's two ExpressRoute services there that are sitting in the Melbourne region. If I wanted to create a new one, I could simply do so by clicking on the Create button on the Azure side, selecting a resource group and a region. So for Australia, I could choose Australia East, which would be homed to Sydney, or Australia Southeast, that would be homed to Melbourne. These are the specific compute regions within the cloud environment that we're going to build the circuit. The other ones that I've built are in Southeast, which is mapped to Melbourne, but I might choose Australia East, which is Sydney. I could indicate that with a service name. I'll just call that SID ER in this case. And in terms of the port type, we're actually utilizing a provider, being Megaport, to get to this connection, and typing in Megaport at that point, we'll obviously select those ports that we have available. Now, I showed you in the Megaport portal that quite exhaustive list of locations. This is the roll-up of those locations globally. So even though I have already selected the Sydney region in this case, the global network of Microsoft ports where they meet the Megaport network is actually distributed here. So I can actually utilize some of the Microsoft backbone components as well as the Megaport backbone components to route. If I choose Melbourne, in this case, we can then see the speeds that are available. For the purposes of the demo, I've shown 50 megabits per second. We can, as I mentioned, do up to 10 gigabits per second. I will not go into specifics on the SKU or the routing type, so local, standard, premium. Suffice to say, standard is what we generally use. Local will keep those routes solely within that specific region, and premium will allow that routing on a global basis. So routing between a Melbourne on-ramp, for example, and a region that was in the US, that would be leveraging Microsoft Global Backbone. But you can use the Megaport backbone, so I'm just going to be using standard in this case. The billing model, metered and unmetered, these are unlimited, sorry, these are effectively pricing points, and the same with the SKU and the bandwidth. They are the components that are used to calculate the Microsoft side costs, so not going into great details there. But as I mentioned, I'm going to exit out of there, and here is a ExpressRoute that we have already requested. This is currently sitting in a status of not provisioned, so I want to change that. I want to actually make that connection. We can see underneath here, there's actually 3 peering types. There's Azure Private, Azure Public, and Microsoft. Now, this is a little bit of a legacy where there are only 2 actively available for new customers, the Azure Public in the middle. It is a previous service that has been migrated and rolled up into the Microsoft peering type that you see at the bottom there. So we're going to concern ourselves with Azure Private and Microsoft for today. The item that I want to take note of is this service key. So I can copy that particular service key, and where I have had that request in the Megaport side portal, I can paste that service key in. And what's happening here is actually a live API lookup. So the Megaport environment is querying Microsoft for those 2 handoff points that exist on their network. And we can see that specific key, Microsoft has made this selection on our behalf, that 2 of those peering locations, they're separate routers, separate what's known as MSEE or the Microsoft edges. They have been made available in the blue and the red diversity zone at NextDC M1's facility. So that choice is made for me. I can't specifically influence which data center it is. I can specify which region or which metro that drops into. In moving ahead, I can select Melbourne Primary, and I can obviously reuse that key at a later date, and I'll come to that on building diversity. Giving a name to that connection, so I'll call that the Melbourne connection. We can see that a price is returned. That no minimum term or month-to-month value matches the one that we got when we did the price evaluation. I can also take that on a 1, 2, or a 3-year term, so that gives some more flexibility. This is probably not new or quite standard. It's been the approach to building an ExpressRoute service for some time. However, scrolling down, this is where I wanted to spend a little bit of time today and hopefully get some questions on the Azure peering VLAN. So this is in effect breaking out Q and Q. And I showed on the Azure side those peering types. So there was 3, but we'll just talk about 2. If I simply wanted to gain access to my VNet, i.e. my Azure private resources, but my equipment that I was using to terminate this did not support Q and Q, this is the toggle that I would use to actually make that service live. All I need to specify after turning that on is the specific VLAN that I was going to configure in the next step on the Azure side to indicate that peering type. So for example, if I was using VLAN 100, and I'll use that for demonstration as it will be sensible when we head into MCR, I would select that Azure peering VLAN as 100, but I may wish to land that on a different customer side VLAN when it actually attached to my port. So for the purposes of demonstration, that VLAN 100 that existed in Azure to access my specific peering would be mapped across the Megaport network as a single tag and would land on my port as 1234. Now, previous ways of working around this did limit some of the service offerings that customers could use. The way that some customers had enabled the ability to connect to ExpressRoute, but in not supporting Q&Q natively was the button here that says untag. The difference in using untag is that that single Megaport connection, which is valid up to 100 separate VLANs, becomes tied to a single VXC or service offering, in this case, the connection to Azure. So it doesn't limit me from reusing that port for other services to other clouds, or in fact taking a primary and a secondary connection on that port. So this new service, I don't need to hit untag. I can just put a specific VLAN that I wish to choose. It may in fact map to the same VLAN that I'm utilizing on the Azure side. It's generally not recommended to have that, as it can make troubleshooting more difficult when you see the same tag, just to understand how that's been mapped out. But I'll use that for today. Just use 100 on the Microsoft side and mapping to 1234 on the Megaport side. And then I can just proceed to order that. Right, so I'll click on order now. Now, what will happen here is this will step through in a matter of minutes, 2 to 3 minutes. I'll probably continue on whilst that's building, but we will see that toggle change from not provisioned to provisioned. Once that has stood up, it is possible to come back here and manually configure, and it needs to be done on the Microsoft side, the peering details. So this is just a preview of that information that's requested. So an ASN, or an autonomous system number, and then the IP subnets. In this case, I'm just selecting IPv4, and they're a /30, which is effectively a me and a cloud IP address within a specific range. And as I mentioned, they're the VLAN ID. In this case, I've already told the Megaport side to expect VLAN ID 100, which is where I would enter that there. If I wished to put an MD5 hash or a key, I could put that in shared key, although it's not a mandatory value. So we will see that complete, but I won't get to that step of specifically adding those peering types at this point. So moving on to, here's one we prepared earlier. I have actually stood up a service, which is the next one we'll see down here. This is connecting to an MCR. So if I have a look at this MCR, I've created this previously. This is also sitting in the Melbourne region. It's in another data center in Melbourne. And we're going to be building that same connection through to the Microsoft Azure service. I will, in fact, even reuse that specific key. So let's go through and do that same process. As that's building, we can see that same provision, but we don't have any of these peering types yet. Using an MCR, this process and what I showed before about the configuration of the Microsoft side is actually automatically done for us. So it speeds things up considerably. Let's move through here and I'll say add a connection to cloud. I'll click on Azure and then I'll provide that same peering key again. Now this is a valid configuration where I already have this primary committed. It's been used and it's grayed out there. We can see that it can be used multiple times by specifying a unique Azure peering VLAN, but what we're actually going to use in this case is the secondary. And the reason I do that is there's a separate tag that has become available that wasn't available when I was connecting to a port. This time I'm connecting it to an MCR, and that is the peering type flag. So there are tick boxes here that I can select one or both of the peering types that will be established automatically by the MCR and our automation as we step through that. So very little changes. I will call this MCR demo. We're utilizing this 50 megabit per second service. The costs are the same, although we're adding an MCR, and the MCR details are actually blanked out. So I can step through and click on add. And again, it looks very much like connecting it to a port. I won't click order because I've already built one of these. So I'll take you through what that looks like. If I step back here to the ExpressRoute side, I've connected that as this second circuit. The difference here is obviously we've got provisioned, but beyond that, we've stood up all of these environments here on the peering side. So we can see Azure Private has automatically configured a set of IP addresses, as has Azure Public. And the eagle-eyed amongst you have probably noted that that particular IP address that's used for public does need to be a valid routable public IPv4 space. Where does that come from? I hope you're asking. And the great news is we provide that as part of the MVE service. So if I step through and have a look at the configuration of that order, the first one I actually want to have a look at is these green lights. So for those IP addresses, the MCR and this particular VXC service have actually stood up BGP to a live state. I did this before the call just to save time across those addresses. What else have we configured? Well, what's interesting here, and this was automatically done as part of that order process, I didn't need to provide any other networking. We've configured the Azure peering VLANs. You can see here, enable Q&Q. It's been switched to enable by default. And VLAN 100, which is the one that we suggested from the port that we use for the private peering, has been automatically selected, as has VLAN 200. We'll just talk through that very briefly. So VLAN 100, which is available here, is the particular IP address that I show on the Microsoft side. And as I mentioned, the /30 incorporates the two IP addresses. So local IP, that is from the context of the MCR, and then peer IP is the Azure side. We've automatically input the AS values. That's the Microsoft one. This is the Megaport one. And yes, if we step over to the Microsoft peering or the public peering, all that's changing here is that particular IP address. That address has come from the Megaport IP space, which is why we're using Megaport ASN in this case. The other one that's interesting is that network address translation, or NAT, has been enabled, and that's actually done free of charge. So we're enabling NAT, which is taking the public routes that are coming from Azure and making them available to the customer across this particular MCR. It's doing that across private routes that may then land back onto a customer device or router. And just to wrap that up, I've gone through very, very quickly on a couple of concepts there. We've obviously connected to the port, we've connected to the MCR. In terms of the public services that are available, I can then, once that peering type has been configured, add a route filter. And the route filter will enable or disable specific public IP addresses that will be reflected onto that MCR or even onto a customer port where they've gone through that process. So just to give a quick overview, and there's more details available on the Microsoft site. Hopefully we'll step to questions shortly. Those that are on this table here that are highlighted with a red box around them, so Exchange, SharePoint, Skype for Business, or Teams, they are available via Microsoft Peering. However, it is upon request. So Microsoft make that determination as to whether they would enable that for you. Other services such as CRM Online, Dynamics 365, Azure Global Services, which is a developer tool, and probably the big one that we get a lot of requests about is Entra ID, otherwise formerly known as Azure AD. So those directory services or user lookup services that have previously not existed within the VNet or the private compute environment can be stood up in a matter of minutes to make that connection to Azure across that trusted path, across that express route. So it does expedite those connections. Obviously, Megaport are providing trusted, already enabled public IP space, so you don't need to step through that approval pathway if you're utilizing our IP address space. And then we would provide that as a NATed connection back to your physical port or through that particular MCR. So it does enable quite speedy connection. And obviously then if you do wish to pursue connecting to any of the other services, a common use case might be getting access to some SIP trunk terminations or some of the ability to use Teams and push that across a private connection rather than across internet-facing services as well. So I think we've covered a lot of ground there. I'll pause for a moment and we might actually go to some Q&A. I want to make sure that within these sessions we get some Q&A and some fodder, if not to actually answer questions about today's session directly. If you've got any burning questions that are coming to mind, I'll pause and open up to Ryan. How have you gone there? Have you got any questions from the commenters? I will point out before you start that we do have a Megaport t-shirt on offer for the best question today. So we'll absolutely get that available if you feel free to open some questions in and flag who you are. We can send it your way. Ryan.
Sure. So we have a handful of questions.
Awesome.
So yeah, one of them you sort of covered partly in the last slide there. One of them
Yeah.
was basically, can we use ExpressRoute to access Office 365 and Teams?
Yeah. Yeah. Generally, no, to be fair. It's not the preferred path that Microsoft published. There are specific, heavily regulated industries such as banking, where having access to services such as Office 365 over the general internet is not a preferred path. It is something that has become heavily discussed, obviously, in the wake of COVID and other reasons to drive users home. Not having access to Office 365 through a centralized environment, i.e. not needing users to tunnel through a VPN, that is a preferred experience. So general access over the internet for O365 with obviously the zero trust implications of securing those connections is preferred, which means that access over services such as ExpressRoute is generally upon request or with discussion of a Microsoft professional in that area, and they will obviously indicate those industries or white label or white list them for where they're able to access that. But Office 365 or Microsoft 365, as you've probably seen, the O365, M365 labels, it incorporates a very large amount of services. So sometimes that can be seen to mean, I mentioned the zero trust component, the AD services or Entra ID as it's known now, and that is available across ExpressRoute with that public peering turned on. There are another list of services. So check the Microsoft website for which parts they are, and if you believe that you're within that list that can get that white list exception, you can absolutely work through that with Microsoft. But thanks for the question.
Great, thanks. All right, so we have another one here, which is you mentioned earlier using a mix of the Megaport and Azure backbones. Does that mean that we can use Megaport for paired regions in HA design? So I think that's a question around can Megaport be used to access multiple regions if you're running a multi-region deployment?
Yeah, absolutely. So we gave an example today of using Melbourne. And I was utilizing Azure Southeast, which is actually the Azure region that is homed to Melbourne. But for a region pair within Australia, for example, it may utilize regions in Sydney and Melbourne. I showed in today's example a flat rate connection. So it was, that approximate $200 a month for that service. And that was through to Melbourne. If I created an ExpressRoute circuit, I could absolutely do that within Sydney or Australia East and then choose the peering location as Sydney, and that would route from the MCR or port or combination of those on the customer side. No matter where they are, I'll pick somewhere other than Sydney and Melbourne for simplicity. Let's say they're in Brisbane. They could route to both of those regions using our backbone. And a VXC by default is a diverse provided service. It is actually configured in such a way that if a fiber path is to fail, that we will seek an alternate route automatically, and it will route that traffic across it. That then gives you region level diversity, as in I've now got Sydney and Melbourne. I do need to configure obviously compute or failover, so it needs to be replicated in those regions, and that's a consideration to take into effect. But I'm utilizing the Megaport network in that case from Brisbane to land into Sydney and then from Brisbane to land into Melbourne. A combination can also apply. So if I wanted to land into Sydney for both of my connections onto those peering points, but have Microsoft carry the traffic through to the Melbourne region, that could also be achieved. Why would you do that, I hear? Great question. Thank you. The challenge there would be, am I using diverse services or can I force diverse services? And I mentioned very briefly that Sydney was in a unique location where it said Sydney or Sydney 2, not as regions, but as in Azure handoff paths. So Sydney 2 is actually a discrete pair again from where the Sydney on-ramps are located. So it would actually make sense in some cases to utilize the Microsoft backbone to carry Megaport through to Sydney, Megaport through to Sydney 2, and then from Sydney 2, for example, that could actually then land on Azure Australia Southeast. It can get complicated, as you can imagine, very quickly, but that's why myself or any of the other solution architects in the team, such as Ryan, happy to take a conversation a bit further and look at your specific circumstances. But yeah, very good question. Thank you.
Cool. And I think we probably have time for one more. We've got
One more?
another
Yep,
one on the
great.
list here. So
Glad I left time for it.
yeah, yeah. There's actually a couple. So
Sure.
I think this question is really around how the high availability works.
Mm.
So the question is, can the links be connected to different on-ramps? So I think that's can the
Yeah.
links is it like the two links that are part of a circuit? Can customers use two different on-ramps? And how does that work?
So this is probably not surprising answer is yes and no. There's some nuance in that where I showed the ExpressRoute service. And when I say service, I'm really talking about it as a service pair. That key that becomes available when we saw that order process in the portal, it actually provided two on-ramps and they're chosen for you. Some customers have tried to build diversity by ordering two ExpressRoute keys and then choosing a service from both. thinking that they're in different, I mentioned the on-ramp locations or even in different regions. So I'll pick one in Sydney and I'll pick one in Melbourne, and I'll choose a VLAN from both. But that actually doesn't work in terms of high availability. It won't give you access to the Microsoft SLA, which is perhaps the most important one. The ExpressRoute SLA is valid where you have both of those services with valid BGP enabled across from a single ExpressRoute pair. So one key, two services, two separate VXCs. From the Megaport perspective, we can deliver that on a single port, but then that becomes a single point of failure. So the recommendation would be to drive that across two separate ports, obviously in separate zones. Again, I'd recommend a chat with a solution architect, but yeah, the recommendation is to build those services as they're provided, so in those pairs.
Cool. Great. Thanks.
Awesome. Thank you, Ryan.
Uh,
Appreciate that, and thanks for everyone joining in today. I think we've come up against our half hour, but we'll be sticking around. And obviously, as I said, however you're joining us through Zoom or the LinkedIn session, throw us your questions, comments. If you have suggestions for future of these, please let us know. And we look forward to our next session where we can talk. Thanks very much for joining in today.
Thank you, JB. Thank you, Ryan.